Hello, dear students. Welcome back to MKG Online Study, an e-learning platform. Imagine you are building an automatic street light. At night, light on. During the day, light off. Simple. Now, here is the question. Who makes that decision? Is there a tiny person sitting inside the circuit? Is the FPGA thinking? Is it running software like a computer? No. And that's what makes today's topic fascinating. Because hardware can make decisions not by thinking, not by executing software, but by becoming the decision itself. Today, you will discover one of the biggest HDL mind-blowing moments. Take a look around. Traffic light decide when cars stop. Elevator decide which floor to visit. Automatic door decide when to open. Smartphones decide when to turn off the screens. Every modern electronic system makes decisions, and behind many of those decisions is logic, simple digital logic. The same logic we are learning today. Let's compare human thinking. If rainy, take umbrella. Hardware thinking. If signal equals to 1, output on. Looks similar. But there is a huge difference. Human thinks, hardware doesn't. Hardware only follows logic relationship. No emotion, no guessing, no interpretation. Just pure logic. Now let's meet the star of today's video. If SEL y equals to A looks simple, looks familiar, looks exactly like programming. And that's where beginners get trapped because Verilog isn't programming, it's hardware description. This if statement isn't an instruction, it's a hardware blueprint. Now let's expand it. If cell y equals to A, else y equals to B. Very simple. If cell is 1, y equals to A. If cell is 0, y equals to B. Two choices, one decision, one output. Nothing unusual so far. But now comes the interesting part. When beginners see if cell, they imagine software execution. Step 1, check condition. Step 2, execute statement. Step 3, move forward. But synthesize tools doesn't see software. They see hardware. And hardware cannot execute instructions. It must physically exist. So the tool asks what circuit can perform this decision. The answer is multiplexer. Multiplexer is a decision circuit, one of the most important digital components ever created. A multiplexer is simply chooses one input from many options. Think of it like a railway junction. Two tracks enters, one track leaves, the switch decides which path is used. That's exactly what a mux does. Imagine you are having a two inputs A and B, and you have one selection line and one output Y. Selection line is SEL. Two possible inputs, one output Y, one selection line. If SEL equals to 1, output becomes A. If SEL equals to 0, output becomes B. Sound familiar? Exactly, that's your if-else statement. Look carefully. Verilog SEL Y equals to A, else Y equals to B. Hardware marks same behavior, same decision, different representation. This is important. Most HDL students realize something huge. If statement become hardware, not instructions, hardware. Let's say if we are having a enable signal, this enable signals control outputs. So the conditions if enable output equals to data, else output equals to 0. What happens when enable is active? Output passes data. When enable is inactive, output becomes 0. This pattern exists everywhere. Processor, communication system, FPGA designs, control units. Industry uses this constantly. What about multiplexer conditions? Now let's level up. If A, else if B, else. Now hardware has multiple choices, several possible paths, several possible outputs, several possible conditions. And suddenly something new appears. Priority. Suppose A equals to 1, B equals to 1. Order of check matters. Which condition wins? The first one always, because if else creates priority logic. Top condition has the highest priority. Lower condition only execute if earlier condition fails. If this fails, then only this execute. This ordering becomes real hardware. Hardware creates priority. Now remember, our previous videos we have learned always at the rate asterisk. This means combinational logic, no memory, no storage, immediate response. So if we replace if else inside always at the rate asterisk, the hardware continuously makes decision. No clock required. Now add a clock. So after adding a clock, always at the rate postage clock. Everything changes. Now decision occur only at clock edges. Now outputs can be stored. Now registers can exist. Now we have sequential logic. Same if statement. Completely different hardware. That's the power of contest. Now we will compare combinational versus sequential. Combinational, immediate reaction, no memory, input changes, output changes. Sequential, clock required, memory exists, state can be stored. Both use if statement but synthesize create different hardware. Now let's break something, that is, look carefully if cell y equals to a. That's it. No else. What happens when s equals to 0? Who assigns y? Nobody. And suddenly synthesize gets confused. To preserve the previous value, the tool creates memory, specifically a latch. And here is the scary part. You may never have intended to create memory, but your code accidentally created it. This is one of the most common RTL bugs in industry. Professional RTL engineers follow simple rules. Covers every condition. Always cover all conditions. Always think about missing paths. Always provide default assignments. Always avoid unintended latches. Good RTL isn't about writing code. It's about controlling hardware creation. So let's recap. Today we have learned if else create hardware decision. If else often becomes marks. Hardware does not execute software. Priority matters. Missing else can create issues. Missing else can create latches. Verilog describes hardware, not instruction. Today, we discover one if statement, one decision, one multiplexer, real hardware. But now imagine this situation, but we have options. Options 0, 1, 2, 3, 4, 5, so on. Do we keep writing if, else if, else if, else if, else if again and again? There must be a smarter way. And there is, in the next video, you will learn one of the cleanest and most powerful RTL construct ever created, case statement. So you will discover in the next video how decoders are built, why engineers love case, why long if chains become ugly, how case creates cleaner hardware. If you are enjoying the RGPV HDL playlist and want to master FPGA RTL design digital electronics, VLSI and Verilog from the ground up, subscribe and continue the journey because with every video you are getting closer to thinking exactly like a hardware engineer. Thanks for watching. Hit the thumbs up button, like this video, share this video with your friends and do subscribe the channel. Thanks for your support. Thanks for watching.